All right. Hello, everyone. With this short video, I want to delve a bit deeper into the concept of environments with Python. For most of this video, I'll be talking about Conda, which is a distribution of and package manager of Python, and what I would recommend using for this course. But I will be moving towards the end into other forms of environments, what's called virtual env, and hopefully by giving you the comparison, you'll just have that much more insight in terms of troubleshooting any issues that you may be coming up with. So first of all, I do highly recommend that you guys use Conda, and I think for most people this is what you already have set up. I would sort of Conda just makes things easier, especially if you're installing full Conda. It'll include Jupyter Notebook. It'll include Spider. So Conda itself, it's a data science oriented distribution of Python. It includes the Conda functions. So whenever I'm in my terminal and I'm typing Conda, and it sort of allows you to use that to set up your environments. So it's a package manager in that way, and I'll get into sort of the link between packages and environments. It also comes with a lot of like what are called IDEs, integrated development environments. So Spider being one of them, and Jupyter Notebooks being another. And these are essentially ways of using Python. So, and then one other thing, Conda does come with a GUI, but I'll be doing everything within the terminal in a Mac. I would recommend, and in Windows as well, the command line. I would recommend using the command line rather than the GUI. It just gives you that much more insight into what's happening, and it sort of allows it allows you to more easily troubleshoot what might be going wrong. And I'll sort of go into a bit of why that is. So first, here you'll see instructions on installing Conda, and I've actually installed Miniconda. So this command which, if you're using Windows, that's just where. And all it's doing is it's finding out where is this program. This program is living here in Miniconda. So for me, I have a slightly different environment than I believe most people do because I primarily use virtual environments, and I just have Miniconda set up to install packages that are tailor-made for Conda. And Datashader especially, you need Conda to install because there are some prerequisites that the more open pip isn't able to handle. And I'll get into pip as well later on. So, but starting with Conda. So when you install Conda, it'll sort of start you off with what's called a base environment. Usually, and I think you get to choose, but I would definitely recommend using Python 3. I am using Python 3 with the notebooks, and although I don't think anything is dependent on Python 2 or 3, but still I would recommend using Python 3. And so let's sort of look at what Conda is doing. So with Conda, and this page here, this is just, I think I found this just by Googling Conda list environments. So let's see what environments I have. This may be I have installed Conda and I'm not remembering, how to activate the environment. Usually it's just base, but I just kind of want to go through this full process to show a bit about what's going on here. So if I say, I'll go back to the page here. Viewing a list of your environments. So it's either conda info ends or conda env list, and it'll show something like this. So let's see what happens when I do this. And for me, all I have is my base because I'm not using Conda on a regular basis. So I have this, and it's mini Conda 3. So it's telling me where it's located. So to activate and actually just to show you, or sorry, to start out, to activate an environment, you just run conda activate, and then the name of the environment. So in this case, base. And you'll see that you have this base in parentheses, meaning that anything that you're running from the terminal is going to be within this base. Now, let's delve a bit deeper into what exactly an environment is. So if I try to find out where Python is, you'll see that the environment itself, it's listing sort of this, my home directory and then miniconda, and it's just bin/python is where Python is located. If I, and conda deactivate, that deactivates the current environment. If I try this again, which Python, you'll see I'm looking in a different place. So this is actually my global version of Python. This is so this is sort of a global location, and this is usually where global programs like this are located. This is a local location. So like let's sort of inspect a bit more what's happening here. So let's go and this tilde, it's just the same as in Mac and Linux type systems. This is the same as what's called my home directory, so users/Charlie. So I'm going to go here and I'll just print out what's available here. And you'll see quite a few packages here. But one thing I just want to point out is you have some sort of Python specific stuff, but you also have a lot of these like SQLite 3, Jupyter packages. You have, and I don't really have that many packages on here. I should have pandas. Okay, that's interesting. Pandas should be showing up here, but you'll see other packages, things like Bokeh and Data Shader. And basically what's happening is, this environment, it created a copy of Python, and it's creating another place. It's creating another place for packages to go. So the packages are going in this environment folder rather than someplace to be globally accessible by, sort of by this version of Python. So, you're not going to have to work at this level, but I think it's just useful to, have a bit of an intuition about what exactly is happening here. So basically, when you create an environment, there's some directory that's created. Conda, manages all of that for you, and it sort of just allows you to get your list of environments this way. And you'll see sort of separate directories for these. So it sort of has these isolated versions of Python. And these versions of Python, they could be different actual versions of Python. So and when I say version, I mean so if I activate base and I go into Python, you'll see this is Python 3.7, and you could set up Conda in such a way that you Conda deactivate. So you could set up Conda in such a way that you have a base and you have a Python 2 environment, so that you could switch back and forth depending on which version of Python you're going to be in. And for most of your applications, or for most of sort of your work, you probably won't be creating that many multiple environments. it's, you're sort of running these things locally. You're just kind of piling packages onto your base environment, and that's totally fine. You use that locally, and you're just not really thinking too heavily about which environment you're using. You just remember that you're gonna always activate the base environment before you sort of run your any Python files from the terminal. And setting up in this way is good. The alternative is sort of setting up different environments for different projects that you may be working on. And as you're getting more into kind of more formal use cases, so like what I'll call kind of production use cases, you'll want to have in terms of troubleshooting, you want to make sure that everyone's using the same environment. So it helps to sort of have some sort of fresh environment that you're able to share, is a bit lightweight perhaps if it's only used for a single application, and someone is able to sort of know like this is the environment that's being used. So if I'm troubleshooting, we're eliminating any sort of issues of you're using Pandas version 22, I'm using Pandas version 19 or something like that. So that sets up that's just a bit about Conda, and then just a bit more about what Conda does. So most of the time when you're using Conda, you're going to be doing things like so for this project, for example, you're going to need to run conda install datashader. And what this does is it installs datashader into the activated environment. And that's very key. So I think by default, if there's no environment selected, conda just goes to the base. But it's very, 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 very good practice to get into to always run these sorts of commands when you're in the environment that you want to install stuff in. That's just sort of, it helps you think about it in the right way there. So conda install datashader means it's going to set up the datashader package in this environment. So it's not going to install it globally. If I didn't have this activated, it would install that package globally. So and then sort of what else conda does is it's what's called a package manager. So in the course of using Python, you'll be installing multiple packages. Things like pandas, all of these you had to at one point install. And although I think pandas just comes base with conda, so you probably haven't had to install that, but just if like any sort of package, anything that you're bringing in with an import, you're sort of starting out by installing, using either conda install, or we'll get into some other methods of installing packages. And part of what conda does is it manages all of the relationships and between these packages. What does that mean? That means you have, packages can depend on other packages, and and conda manages all of this. So it manages installing prerequisite packages. It manages, I actually don't even know how it does this, but it's kind of, it ends up sort of just working. It'll manage any potential conflicts. So if one package is requiring, and all of this sort of defined, like where one package requires 6 other packages, and you get sort of complex webs of dependencies, conda works out all of that when you're installing these packages. So, and you could sort of think of it like if you had to manually manage all of that, it would be hellish. So, that's providing sort of a lot of value there, making sure that everything is sort of working fine in terms of dependencies. So that's conda environments, and this page, which, like I mentioned, I just Googled conda environments, and they have a full page of docs here. And this is, here you could just create environments doing things like conda create, whatever env you want to create. So if I run something like, and actually here you could even specify the specific version. So if I did want to set up a new environment, I could say something like conda create. Let's say this is Python 2.7. So the version of Python is going to be equal to 2.7. It's getting everything set up for me. Pip, we'll get into in a bit, but pip is the sort of original, more original than Conda, the package manager. So I could just, so now when I do conda info ends, I have now this 2.7 environment. You could see that there's actually sort of a concept of, base conda is in just this mini conda 3, and then there's this ends folder, and then 2.7, so other environments will just be placed there. If I activate it, you'll see I have 2.7 in between parentheses there. And now if I try to find out where Python is, you'll see it's in sort of this /bin/Python. And if I go into Python, you'll see that I'm now using 2.7 rather than another, rather than 3.6, I believe, or 3.7 at this point. So I have Python 2.7 set up here, and let me conda deactivate. So that's creating an environment, and again, within that environment, I could pip install any, or conda install any packages I want. But that environment would need to be activated when I'm doing that. So, so next is getting into Jupyter. Now, if you install Conda, which again I do recommend, the Jupyter should already be set up for you. I use a version of Jupyter that's not associated with Conda because usually I'm not using Conda. So with me it'll be slightly different, but for you guys, the installation of Conda should give you, you should have some place where Jupyter is living. It won't be this, but it'll be something Conda related, and you'll, you're able to sort of access Jupyter notebooks by just running, Jupyter notebook, and that'll be all set up. So, so Jupyter, on one level, it's basically another Python library, so similar to Pandas, Datashader, Plotly, all of those. But Jupyter is also a bit different because it kind of functions at a level, or it definitely functions on a level above environments. And what do I mean by that? So, so for most of you guys, Jupyter should be accessible outside of whichever virtual environment is you've created. So you don't have to, and actually, for me, in my Conda environment, I have a version of Jupyter where the notebook isn't even installed, so I'm not even using that, so I can't use it in base. But you guys in base, it should all work because you're just installing Conda, and that's the cleanest way to do that. So let's deactivate again, and let's, so now if I do switch Jupyter, that's the version of Jupyter I want. And if I go back to here, I'm going to run Jupyter Notebook. So, and the reason why I mention sort of Jupyter and environments is because it's kind of weird, kind of contradictory in a way, because as you saw, there are different versions of Jupyter depending on the environment I'm in, but Jupyter itself can control, can sort of pick environments once it's started. What do I mean by that? So if so right now I just went into Jupyter Notebook. All you do is run Jupyter Notebook from the terminal, and it's sort of hosting itself. You go to, and it'll open it up in a browser. So if I open up this notebook, you'll see this. You'll see sort of a conda. And you'll see the name of a kernel over here. That's actually what this is. And this, I think, is what was key to a lot of people's problems. Is I didn't just use base. I used sort of base on my own machine. So what would happen with you guys? You guys would open the notebook. The notebook itself, all it's saying is I'm using an environment that Jupyter knows as Conda base. And I'll get into what all that means in a bit. But so, the problem is if there's not an environment named Conda base, then Jupyter won't find a kernel and things won't work out the way that you're thinking. So if I so for most of you guys, Jupyter will be associated with Conda. The environments that you create with Conda will automatically be installed in Jupyter. And all you'll need to do is go into kernel, go into change kernel. You won't have as many kernels as I do, but you'll have something like base or year 2.7. Select that, select the specific environment that you want, and then run it. You'll see the text changes over here, and then rerun the notebook. And that should match, and that will match this over here if you're just running all of this in Conda and aren't sort of associating anything, setting up these environments in relation to Jupyter on your own. So now that's probably the simplest way. That's going to work in 90% of cases. But I do want to delve deeper just to give everyone a bit more context into how Jupyter is dealing with these environments. So I sort of mentioned this is kind of it's kind of contradictory that on one level Jupyter is considered a Python package, which means that it's associated with an environment. So that means that as we saw here, I have different different locations of Jupyter depending on which environment I'm in. On another level, Jupyter is sitting on top of all of this because, as you saw, I just switched environments. So it's weird in that way, but so far, there's not really, it's not really anything can break with Jupyter. So you could start Jupyter from within your environment. You should be able to start Jupyter from outside of your environment. For everyone on the call, or everyone on seeing this, I would recommend probably starting it within the base environment, but there's sort of not really that many problems that you could run into there because you could always switch the kernel from here. So now let's delve into where Jupyter is getting the information about the environment. So this, and this was just found just Jupyter list kernels, and this will tell me how to list my kernels. And I believe there's a version of this that rather than saying IPython, it says Jupyter. So I'm actually going to be tweaking this a bit, but what I'm going to run is Jupyter kernel spec list. And so this gives me this information about what kernels I have. So it's listing the kernels, and it's listing some sort of location. Now, this location is different than the environment locations that were being listed. So let's take a look at what let's take a look at one of these. So I'm going to go in here. So I have my environments here. Go into Conda base. And you'll see this kernel.json. So let's find out what's in that file. So, you can see some information being passed here that's essentially defining this kernel for Jupyter. And and what's happening here is, and don't worry too much about like what all of this is. What matters is there's some sort of location. So here, this is the path that if so here, this is my Conda base environment. It's pointing to this location, which is where Python is installed on in my base environment. And it has a display name. This display name is different than base. Again, probably this contributed to confusion. But what really matters is this kernel is essentially has this little JSON. This JSON is telling Jupyter that the kernel is located here. So when I'm executing Python commands, that's what I'm using. Now, most of the time, again, this is very much just to give everyone the background. You're not going to have to be going into this on a regular basis, but I think this really helps in terms of, letting everyone know what environments are doing and hopefully making it easier to troubleshoot on your own. So that's what's that's where Jupyter is getting its information on kernels. For you guys, you're probably not even going to be adding new kernels because Conda takes care of all of this for you, and all you're going to need to do is make sure that you're using the kernel that you should be. So this is something that when you open up a notebook that's coming from someone else, there's nothing that's really controlling what the name of their environments are. So, one thing that you should always be thinking of is, am I using the right, what environment do I want to use for this notebook? And, sort of set that up yourself, sort of, go through that thought process on your own, rather than, because otherwise the notebook sort of carries its own information of saying I'm using a kernel called Conda base, and it's going to do that. It's going to go into the JSON, know that it's going into the base Python environment, and use that kernel. And if it doesn't see that, then weird things. Then it's not going to run for you guys. And so that's the overview of how Jupyter handles environments. And then one more thing. So this is a post that explains how to manually add environments to Jupyter. Most of you guys aren't going to need to worry about this, but I do, again, just to make sure that everyone is getting more information. I think like this is just helpful to understand the mechanics of what's happening. So this page is sort of meant to answer the question of I have some environment. In this case, it's using what are called virtual environments, but this works exactly the same for Conda environments. And it's not associated with Jupyter. I want it associated with Jupyter. So we could actually go through this with the environment I had just created, this 2.7 environment. So as you'll see in here, I created this environment, but we're not seeing it in Jupyter yet. I had mentioned, for me, this is because Jupyter is separate from Conda in my computer. You guys probably won't have this issue. When Jupyter is associated with Conda, Conda magically works it out and associates the environments. But there are actually other reasons why you would want to manually sort of set up environments in this way. One of them being that Jupyter is meant to work with other languages aside from Python. Actually, the name, it just comes from Julia, Python, and R. And like for example, I have an R kernel here. And if I were to do this, I could actually execute R code within Jupyter, and that's pretty cool. So how would I be able to associate a loose environment with Jupyter? And here this just goes into some background on Jupyter on environments rather, but in particular, so this is just creating virtual environments. You don't need to worry about that, but you should be recognizing that this is kind of similar, especially this source activate. That's kind of similar to conda activate. So that's really what the analog is. But what matters is this IPyKernel library, and IPyKernel is essentially what installing IPyKernel in an environment allows you to install it into Jupyter. So how does that work? So now I'm going to activate 2.7. I'm in 2.7. I'm going to conda install rather than pip install. It's installing IPyKernel. And then I'm going to run this command here. And I believe I'm going to run that with Jupyter. No, I'm sorry. I'm going to run that with IPython. I'm sorry I'm being confusing with switching back and forth between Jupyter and IPython. I believe most of the time it should be the same, but I'm just going to use this IPython syntax rather than Jupyter. So yeah, apologies for being a bit unclear there. And so what did I do here? So I copied this, I sort of typed out this command, just IPython kernel install, the user flag, so that means I'm doing it locally. And then I'm naming it within Jupyter. So I'm naming it conda 2.7 so that I could differentiate it from my other non-conda environments within Jupyter. And what did it do? It just said it installed this. You could see this user's, this here. If I go there's a kernel JSON here also. And if I look in that kernel JSON, you'll see that it's going into this env miniconda env 2.7 and then Python. And it's being named conda 2.7. And then when I go back to my Jupyter notebook, and I'm probably going to have to restart this here. So let me close out of that. I'm going to restart Jupyter Notebook. And now, when I open up this notebook, I could go into kernel. I could go to change kernel. And now I'm seeing conda 2.7 here. So that ensures that the kernel is associated with the Jupyter Notebook. So to bring this back to the troubleshooting requests I was getting for Module 2, it seems like a vast majority of them were, maybe not vast, but definitely most of them were sort of about, essentially the failing was happening just on the importing of these packages. So and what's and those sorts of errors. It's I mean, if it's not seeing that that package, that means that the package isn't available to whichever kernel you're using, which means that you're probably in the wrong environment. And using sort of the new knowledge you have from this video, you should be able to troubleshoot that a bit further. So so that's so basically, like if you are seeing error messages where it's failing on import, that's going to be, like it's going to be this sort of troubleshooting that you would need to work with. And then in terms of the data, this was updated a bit late, like 2 weeks ago, just when this was first due, after our second meetup. So I did have to change a few things. So this is actually looking at a new version. Oh shoot, I actually did correct it twice, which means it is still wrong. So the link is using version, and that's my bad. So basically, what I would do with this, so I was wrong here. This should be version 18. So again, I'm just Googling this. You have the version of version 18 here. This is the .csv, and that's going to be the same as this pd.read CSV, the version 18. That should work out if you just unpack the zip file. For version 17, it sort of worked out in this form, and then you concat all of them. And there's also the annoying thing of these were capitalized in version 17 and not in version 18. So I apologize for getting this wrong here. So I'll just correct that link. But if you have this version, just Google New York City Pluto version 18, and then that should work. So now, one last thing I want to do is talk about using environments and Dash. So Module 4 will be using a framework called Dash, which is similar to Shiny. It's sort of a framework of building interactive, data-driven web apps, basically. And we'll get more into that as we approach that module. But just from a meta sort of, setting up your environment and how to think about, using tools like this, you'll see I'm using a tool called I'm using a text editor called Atom. And actually, I'm sorry, to back up, before we get into Dash, I had mentioned, I'm very agnostic in terms of what tools you use. Like some people mentioned they were more comfortable with Spider. The only ask I really had was with Spider, make sure that, you sort of write a .py file that at least mimics a notebook like this. So I'm able to, include lots of comments, and kind of, with the expectation that I'm, sort of probably going to be running it piece by piece. And I don't mind if you really sort of prefer using Spider, but keep in mind I'm not checking this on Spider. I'm checking this on Jupyter. And it's fine if the .py file has enough information where I'm able to either copy and paste things, and sort of make it work as a notebook like this. Sort of test out modular blocks of the code. So just sort of keep that in mind, that if you are using some other environment like that, it has to be, someone reading it would have to sort of know how to run it, because that might not be apparent with just a .py file. And then one other thing to mention is, because I'm not using Spider or any of these other IDEs, I'm not really going to be able to troubleshoot any sort of issues that you're having with them. So if you guys have problems with Spider, and it's not running Data Shader, there's kind of going to be little I could do to make that work, to get that to work for you guys. So keep that in mind as well. And then, so getting back to what I was talking about with Dash, Dash apps, they actually don't There is a workaround to make them work in Jupyter, but Dash apps are meant to be sort of standalone Python scripts. So here I'm using a text editor called Atom. You guys could use whatever IDE or text editor you want. The only thing I would mention is if you are using a more full-featured IDE, something like Visual Studio or PyCharm, Spider, something like that, there's a lot of them come with sort of consoles in them. A lot of them have concepts of packages of like projects and integrate with Git, sort of do a lot of like these integrations for you. In my experience, these sorts of tools, like I imagine they're great if you're kind of purely working within this tool and you're not really going outside of it. But in my experience, I've just found these sorts of tools, like in working with clients and students, these sorts of tools just really make it difficult, if you're trying to do something slightly different from however they're prescribing you to do it. So I'm going to again recommend that when we are working with Dash, when we're running Dash apps, that you do it from a fresh terminal. And in particular, with things like environments, this lets you just have full control over which environment you're in, and sort of makes it also easier to debug either by yourselves or if you have questions that you need to bring up with me. So basically, whatever tool you're using, when you create a Dash app, you'll create some sort of app.py. With more complex apps, you'll usually have a folder with the app.py and with other supporting files. But for now, we're thinking about sort of a simple app where it's just a single app.py. And then we have our environments that we that we have within our terminal here. So I'm so don't get too concerned. I'm just not using, again, I'm not using Conda. So I have this VN3. This is my main Python 3 virtual environment. And so that means I know I'm using this version of Python. I know that I have all of these packages installed. And all I do is python app.py. I would need to be in the right location. Python app.py. Now the app has started, and we'll get into what Dash is doing, but just from a meta perspective, just consider this like you're creating a .py file, and this .py file is going to be your Dash app. Try not to get too integrated with sort of whatever sort of associating your environment with your IDE, unless sort of what I explained with Jupyter, because if you are using another IDE, I won't be able to troubleshoot that. You'll be on your own there. So I recommend I recommend just sort of think of your whatever IDE as a text editor and save your .py file, then move to an external terminal, an external command prompt, and run the file there. And so I'm running this. It says, it gives me the location that it's running, and 127.0.0.1 is the same as localhost, so I could just do this and access the Dash app, which, yeah, there we go. So then I have my Dash app here, and we'll be getting into this with our module 4. So I did mention I was going to go into virtual, yeah. So basically everything before, this is sort of, I recommend you guys use Conda. I recommend you guys sort of stay within that ecosystem. That makes a lot of things work, just work. And everything else that I'm going to talk about from now on, this is sort of just a bit more advanced, just meant to, give everyone like more of a context of what Conda actually is doing, what it's built on top of, and, like sort of what other options are there. So you'll notice I'm not using Conda commands. I'm using what's called virtual environments. Virtual environments, so there's a library called virtualenv, and virtualenv allows you to create virtual environments. They work very similar to Conda, except one sort of key user experience sort of thing you'll notice is if I create a environment, I create it wherever I'm running it. So here I'm in module 2. You'll see this is all I have here. I just added this app.py. If I run and let's go through what I'm doing here. So this Python 3, this is my global version of Python 3. I also have a global version of Python 2, which is just Python. This -m essentially means I'm running virtual environment, but I'm running Python 3's version of virtual environment. So that means I'm setting up a Python 3 virtual environment rather than a Python 2 virtual environment. And then I'm naming it my environment. So I do that. And you'll see that it creates my environment here. And it's actually creating it in this environment here. So if I go into, you'll see, there's similar to what we were seeing before. We have sort of our what's called pip. We have sort of some libraries. We have our version of Python, etc. And if I run so what I'm running is sort of this source command, and then this activate script. And that does the same thing that Conda was doing. So Conda is actually built on top, I believe it's built on top of virtual environments. It's sort of a wrapper of it. And then with virtual environments, because it's not associated with Conda, Conda is functioning as a package manager as well. So what does virtual environments use for package manager? So it uses what essentially a more base, level, sort of a more lower level package manager that's meant for sort of all Python use cases. So if you're purely web developing, you'd be using this, not just sort of for the data science use case. And it's a tool called pip. So right now, if I go into Python, see it's 3.6, and I try to import pandas, and I'm getting an error because there's no module called pandas. So I'm going to exit. And again, I'm making sure my environment is activated, and I'm going to run pip install pandas. That will get the latest version of pandas for me. Get all of the prereqs, so you can see it's installing NumPy for me. It's one of the prereqs. And then all I need to, once this installs, it's taking a while, but all I'll need to do is go into Python and sort of use those. Now if I go import pandas, that works for me. And so with virtual environments like these, especially for more professional production applications of Dash, when you're thinking about deploying apps, it makes sense to sort of have these more lightweight environments that are meant to run a specific app. So I would have an environment that only has these libraries. It doesn't have anything, no scikit, no, in this case, I'm not using it. So it only has these lightweight environments installed. And, that sort of also helps with debugging because I could send essentially a version of the environment over with a sort of I could send to someone else who I'm collaborating with, give them instructions on how to build this environment. And how does that work? So if I run this command, pip freeze, you'll see it lists sort of these libraries here with the syntax specifying the version. If I run, so what I'm doing is I'm sort of outputting into a text file. So you'll see this requirements.text got created, and I have sort of all of these libraries here. And what I'm able to do is if I were to send this, if I wanted a colleague to troubleshoot this app.py, I would send this app.py and I would send this requirements.text. And what this person would do, they would receive this requirements.text, they would create a fresh virtual environment, then they would run pip install -r requirements.text. And what that does is basically sets up the exact same libraries, the exact same version numbers that I had. So they would have the exact same environment I have. They would be able to troubleshoot what might be happening. But we'll get more into this as we're running Dash. But the key takeaway here is Dash apps. You have a Dash app at the end of the day is a script, and so it'll be a .py file, and that .py file is ran from the terminal. And I recommend doing all this from a fresh terminal rather than sort of a terminal that is included with Spider or anything else there, because this sort of gives you the most control about which environments you're using. So I hope this has been helpful for everyone, and I'll continue monitoring the Python discussion board for feedback. But just in terms of sort of what I'm aiming for, I really want to sort of get past these problems that we're having with Python, because we are going to be using Python later in the course, and I want to try to invest the time now to make sure that we're all properly using it. So again, I hope this was helpful, and I'll see everyone next week for our regularly scheduled meetup, and we'll be able to talk further about this. Thanks a lot.